You are watching the Notre Dame NMR Operation and Concept series. I am Evgenii Kovrigin, your NMR director. In this episode, I will discuss how properties of the NMR sample may cause shimming to fail and what to do to prevent that. When top shim fails on your sample or formally completes but you see bad peak shapes, you need to determine what causes the problem, spectrometer or your sample. First, you should insert a standard CDCl3 sample, reload a standard shim set, lock and try to shim. If the standard sample shimming fails, the instrument has a problem. Report it to us immediately. However, if the standard sample shims well and your sample doesn't, your tube has a problem. We will consider several possible scenarios when the user sample may make it difficult or impossible to lock and shim. First case. I did not put enough solvent. The meniscus intrudes into the NMR coil area. Solvent-air boundary makes a huge distortion of the magnetic field, which is not possible to compensate with the shims. Shimming will fail on such a sample, and you will never have resolved spectrum with nice peaks. Therefore, we always have to load enough solution to make sure the sample looks like a continuous column for the NMR coil. For a standard 5mm tube, loading 0.6 ml of a sample will guarantee the right sample length. Similarly, a huge distortion will result if the bottom of the tube gets too close to the NMR probe detection area. In fact, for shimming to fail, the meniscus or the bottom of the tube don't need to enter the NMR coil region. It is sufficient to just get close enough, because magnetic field is continuous and these boundaries are fuzzy. This is why we need 40 mm of sample height to keep the bottom and the meniscus sufficiently removed from the NMR probe detection area. What if I load more solvent, maybe 100 mm in height? Will it make things better? No, it won't. 20 mm away from the center is far enough, so moving out further doesn't matter anymore. A final important point. Just below the tube in the NMR probe, there is a temperature sensor. If you push the tube deeper than the bottom of the depth gauge allows, your sample will damage the sensor. This is why we must always use the depth gauge to set the tube to its allowed depth. In some cases, it is your sample composition that may prevent shimming. If the sample solution is not homogeneous due to precipitation, formation of bubbles due to dissolved air, or phase separation between poorly miscible liquids, this creates additional distortions to the magnetic field. A precipitate particles floating in solution strongly distort the field and will make it very hard to shim. As the precipitate settles, it makes solid liquid boundary that will prevent shimming. A simple solution. Let your sample stay in a test tube at your experiment temperature for several hours. The particles will settle to the bottom. Then you will take the soluble part of the sample into the NMR tube and achieve perfect shimming. If your solvent tends to dissolve air, gas bubbles will appear if the experiment temperature is higher than the room temperature. Upon warming, the solubility of air decreases and it will form bubbles on the walls of the tube. You may be able to shim initially, but as bubbles develop, typically in the middle of your NMR experiment, the magnetic field will be distorted and your sensitivity and resolution will be gone. This is not common for organic solvents, but very common for aqueous solutions. Samples in aqueous solutions are often kept cold to prevent bacterial growth, and they will dissolve a lot of air upon cold storage. A simple solution is the same. Let the sample warm up to the temperature of an NMR experiment and keep it at this temperature for some period to let all bubbles come out. You can accelerate degassing by placing an open tube under a mild vacuum. After that, you can safely load the gassed sample into the NMR tube. Phase separation in the sample will also dramatically degrade your shimming. A new solution-solution boundary will make huge distortion to the magnetic field. This may happen with mixed liquids, which are not completely miscible. There may be no phase separation before the experiment, which will allow you to shim perfectly initially. But once the sample develops the boundary, your shims will no longer compensate for the field distortion, and peak shapes will become bad, giving you less than useful spectrum. A rule of thumb: if you expect some phase instability, let the sample sit on the bench for several hours at the intended temperature of your experiment. If phase separation happens, take the phase you want into the NMR tube, and you will be able to shim for a good spectrum. Megahertz rating for the NMR tube is very important when making the NMR sample. All NMR tubes are made to specific standards. The standards for 200 MHz are lowest. The 400 MHz needs better tubes. 500 and 600 even better. 800 MHz needs tubes of highest quality. You should use tubes rated at least for the magnetic field you use. In other words, you can use 800 MHz rated tube in the 400 MHz magnet, but not the other way around. Sometimes people would buy economy tubes with low megahertz rating because they're less expensive. However, what you don't pay in money for the tubes, you pay in your wasted time and poor quality of your results. Remember a rule of thumb: use only NMR tubes with the megahertz rating equal to your NMR instrument or higher. Sometimes there are defective tubes with some contamination inside their glass that gives magnetic interference. You cannot see it by looking at the tube. What you do to confirm or rule that out is to take a different tube or a new tube, load it with 0.6 ml of deuterated solvent, and lock and shim. This is a positive test to ensure that the new tube is good. Next, take your sample out of the suspect tube, load it into this one, and lock and shim. If your sample shims in a new tube, your other tube is defective. Throw it to trash. If it doesn't lock or shim, your sample solution has yet another issue that I didn't cover. Please contact me then and we will investigate. In summary, for success of your shimming, please follow these simple rules. Buy NMR tubes rated for your field or higher. Make sure your samples are soluble and homogeneous. Load enough solution to make 40 mm tall solvent column. Use depth gauge to set the tube in a spinner. Test the standard sample if your sample doesn't shim.